Okay, now how do you find R squared? R squared is sum of squares of regression. So model is your regression divided by the total sum of squares. So that's your R squared value, which is about 86%. Okay. Now adjusted R squared, okay, here is the formula for adjusted R squared. Okay, so you go 1 minus, okay, so n minus 1 is the total degrees of freedom, alright, divided by n minus p minus 1 is the error degrees of freedom, times 1 minus R squared. Right? That's your adjusted R squared. So slightly smaller than that. MSE is your mean square error, and root mean square error is square root of that. Okay. So which is what you see in the results. Okay, so here you'll see R squared, adjusted R squared, then here is your root mean square error 1315.45. Okay, so that's what you see here. Okay, now let's look at the individual coefficients. So here we have the parameters and the parameter estimates and the standard error and so on, right? So let's copy that, bring it over here. So I'm going to copy it first. I'll copy it here, then splice it, text to columns. So we'll do fixed. So here we don't need, well, let's keep it like that. All right, finish. So now we don't need the intercept, we need only the predictors. Okay, so those are the predictors, and well, let's bring in intercept also, so you will have all the coefficients. So these are the coefficients. So our regression estimation would be b sub 0 plus, okay, b sub 1 times the variable, b sub 2 times the variable, and so on. Okay. So now we have the standard error. Oh, let's move this a little bit. So, standard error of the coefficient. Okay. You really don't need to do this, but I want to show you how to perform the test. Okay, we don't need a test for intercept. So these are the coefficients and these are the corresponding standard errors. Then the t-value will be the coefficient divided by the standard error. And you see that's exactly the same as what we got in the SAS output. Okay. Now the p-value is, you can use t-distribution, okay, t-distribution of two-tailed test, okay, and we need to make this into an absolute value. The t-value should be converted into absolute value, and then the degrees of freedom is the same as the error degrees of freedom. that will give us the p-value, okay, and let's make that into percentage. Here I need to, the degrees of freedom should be absolute referenced. Okay. So from here we can say which ones are significant. We can set up a if function for that, but I'm just going to just type that. Okay, these are the yes, sorry. These are the ones that are significant of these. The rest of them are not significant, and with the coefficient and standard error, we can compute margin of error and construct a confidence interval, if you want. All of these are techniques that you would use for explanatory modeling.